Hi, my name is Cassie, and I'm going to be talking about ecological representation in Western U.S. protected land, focusing specifically on Bear Ears National Monument. This is just kind of a brief general overview. I'm going to be talking kind of fast, and I did a lot of dense, heavy stuff here, so this is just kind of to give you a general idea of what you'll be learning today. So first I'll talk about the relevance of my study, kind of the history and technicality behind it all, followed by my research question, coupled with the kind of studies that I use to answer that research question. Then I'll talk about the significance of barriers, following connectivity along with my GIS, and then the takeaway. The addition of Bear Ears National Monument has caused pushback on both the monument itself and the Antiquities Act of 1906, kind of mimicking the preceding 1970 Sagebrush Rebellion. Now, this local pushback has led to the suggestion of amending the act and even rescinding or shrinking the monument itself. The research that I conducted will hopefully offer insight on how significant this new monument is biologically, as well as give cause to keep the act and leave the monument as is, despite current protests. Now, you may already have some information about the Sagebrush Rebellion, but in this case, this project exists because of that rebellion, so the only things that I will say are that the previous Sagebrush Rebellion happened due to the Federal Land Policy and Management Act of 1976, which essentially resulted in the increase of government management over all federal lands, ending things like homesteading and living off public land, simply because management was intensified. Now, present-day rebellion focuses more on the Antiquities Act, which is a law passed by Congress that essentially authorizes the president to protect landmarks that are of historic or scientific interest. This happens by pushing the status of these areas to national monument, therefore increasing protection, upsetting many locals who feel like it's not right that their land and natural resources be controlled by the government who have little experience on such land. Now, I talked a lot about this national monument and the troubles it's caused, but I haven't shown you yet. So this is the proposed areas for Bear Ears National Monument, henceforth known as Benham. It's important to note the sheer size of the monument and the wilderness area it contains and is surrounded by for later on connectivity. Now, to aid in the education on the matters of this present-day rebellion, I asked two questions, really. One, how does the Bear Ears National Monument contribute to connectivity of Western federal lands, which will kind of be explained why it's important later. And two, how does this monument contribute biologically? Now, you may be thinking, why is adding new land so important for conservation? Why fight for this and hasn't there been enough done already? Well, contrary to popular belief, in the U.S., biodiversity loss still occurs despite our extensive system of nature reserves and national parks, national wildlife refuges, and designated wilderness areas. Now, to fully understand the importance of barriers, I'm going to first discuss current nature reserves and their expression of biodiversity. In assessing these U.S. nature reserves, distribution of the land within and outside of them was examined with respect to geophysical characteristics. Now, the areas to be examined were found using maps and spatial data layers to provide the boundaries of about 2,500 reserves, and these areas were those having permanent protection from conversion of natural land cover, corresponding with S1 and S2 management categories. Now, the geophysical characteristics include soil productivity, life zone based on elevation, and ecoregions. The broad ecological domains were determined from a previous study called Bailey's ecoregions, and the one used in this study were Western humid temperate, Eastern humid temperate, and dry temperate. Now, the results show that 60% of all nature reserves, their land ranks in classes 4 to 5 in soil productivity out of 7, 7 being not that great, and predominantly mid to high elevations. Of all the coterminous land in the United States, 45.5% is eastern humid temperate, with only 1.5 being seen in these nature reserves. 48 is dry temperate, with 7.8 being in nature reserves, and 6.5 is western humid temperate, with 12% being in nature reserves. This concludes that the distribution of nature reserves shows the same pattern no matter what. They're limited to sites of higher elevation and less productive soil, and therefore they don't express their biodiversity adequately due to the reduced quality of land. Now, not all protected land in the U.S. are nature reserves, but it's important to realize that these nature reserves are areas quite literally used to preserve flora, fauna, and physical features. These areas have been designated to preserve biodiversity richness, and yet the land is of such poor quality in most cases. And I bring this up because national parks kind of follow in the footsteps of preservation of wildlife, but they thrive mostly because they're aesthetically pleasing. And if the land that's used to preserve biodiversity is of poor quality, what can we expect for our national parks? In a study done by conservation science partners, it kind of shows us what we can expect. It's shown that current U.S. protected areas are insignificant in guarding against species and habitat loss. This is because to have ecologically functioning protected areas, a sufficient land base, a variety of habitat enveloped in the land, resilience to climate change, and interconnection are all required. And protected land these days rarely represents this criteria. Now, in addition to the criteria not being met for protected lands, areas of the U.S. that are undeveloped and unprotected are sometimes used to enhance the effectiveness of this protected area network. Now, these are sometimes hindered by the expansion of energy development, mining, and timber harvesting. And because of this, there is careful selection of areas for conservation based on the ecological significance and context. This is where Benham comes into play, as it presents the opportunity to conserve key elements of ecological function and protection of said functions. Now, in order to assess ecological benefits, 12 landscape level indicators were established. These indicators are described in the graph to the right. Now, each of these indicators were also used to map ecological connectivity and intactness, biodiversity, resilience to climate change, and remoteness/threats as they're a function of these characteristics. For example, night sky darkness could be a function of remoteness, and oil and gas resource potential could be seen as a threat. Now, to find significant values of each of these indicators relative to the larger landscape, a simple scoring system based on percentile ranks was used. And in order to emphasize the study, it included all 11 western states and compared those national parks to Benham. This analysis indicates that Benham contains multiple important conservation features. As you can see on the graph to the left, Benham does substantially well compared to most other national parks. Benham being the bar that you see, and the other national parks in the 11 western states being the dots. Now, Benham falls behind in just two categories, vegetation diversity and climate resilience, but you do have to take into consideration that this is a canyon land, so it's not going to have very high diverse vegetation, and it's going to be quite easily affected by climate. Now, the maintenance of connectivity is known as one of the most important features of biodiversity/landscape conservation. Even compared to all other Western lands and jurisdictions, exceptionally high values for ecological intactness and connectivity was established within Benham, scoring in the 92nd and 90th percentiles. Results also point to Benham containing highly distinctive nature and irreplaceable value of this area with respect to rare and endemic species as well as diverse habitats depended on. For my research on connectivity, I used Linkage Mapper, which is a new GIS tool designed to support wildlife habitat and connectivity analysis. And how it works is that it uses GIS maps of core habitat areas that are established against a resistance layer to identify and map natural corridors between these core areas. Now, the cell in the resistance map used are attributed with a value that reflects energetic cost, difficulty, or morality/risk of moving across said cell. And this value is determined by land cover, housing density, and it can be combined with species-specific landscape resistance models. In my study, I first needed to assess protected land close enough to barriers so that the distance wasn't too unreasonable for animals to trek across. These would be animals like kangaroo rats, mole deer, desert cottontails, things like that. And so the places I chose to connect were Benham, North Escalante, Canyonlands Parks, and Arches. And once I knew that, all I had to do was enter the rest of my model inputs. My resistance layer was based off a wilderness layer, which was provided by Paul Laura. And that included things like land cover, soil productivity, population, roadless areas, things like that, which is why it was such a good resistance layer. And what we have here basically are the results of this linkage mapper tool, which I will explain in detail. Over the whole of Utah, you have that wilderness area. So things that are colored green are areas that aren't populated. The land cover is very natural, very untouched desert land that you have there. The areas that are red are more heavily populated, and the land cover has been altered, obviously, and where you're going to have people, you're going to have roads. So these are places that are just very hazardous for animals. Specifically for the corridors, a darker green is a cost distance layer that was created by Linkage Mapper itself, and that was made surrounding the corridors themselves and were established from the input data. So what you see here is that there are 5 corridors established between Benham and these other areas, and it's clear to me, due to the dark green color on most of them, that these areas run over very productive good land. It does also help that Benham is so big and is on higher elevation because people don't really trek up higher elevation, and it's been known that people don't do that. Which is why you see Arches and there's a red dot over there. And that basically is because there is a town that surrounds Arches, which is why it's redder towards the beginning of that corridor, leading all the way down to North Escalante, Canyonlands National Parks, and Benham. But as soon as you get across that threshold, it'll be easier for animals. And this is basically because Arches is on lower elevation. And so what this basically establishes is that Benham contributes greatly to connectivity. If Benham wasn't there, it would be a much, much longer area for animals to have to trek across. And although it is on good land, you can see in some of the areas that they are yellow. So that land isn't that great. So there is a little bit of cost distance there. Now, I'm hoping by now we've established that Benham is right up there with other Western national parks and deserves the same respect. But it's also important to note just how biologically significant Benham is in regards to connectivity, endemic species, and a highly distinctive, irreplaceable nature. Not only is Benham biologically significant, it has the potential to be economically significant, and I recall in an earlier study done by Megan McFarlane in which she assesses the addition of national parks and national monuments on local economy, and the conclusion of that study is that national parks slash national monuments actually aid in local economy. They bring in money, they bring in jobs, they bring in revenue. Everything is aided. And so, just to wrap it up, it'd be in Utah's best interest to leave Benham as is. These are my works cited. If you didn't comprehend anything I said and want any more information, you can go to these websites and they'll teach you all that I know. And thank you for listening to my PowerPoint presentation.